In this example, we're given a circuit that is driven by two fundamental different sources. So we have a voltage source and a current source in here. I'm saying fundamentally different because if you pay close attention to their frequency, you'll see that the voltage source is operating at a 5t and the other one is a 10t, or the omega for the first one in here is simply 5 radians per second. Okay, and I'm going to call it omega 1, and omega 2 is just basically 10. And as you recall, inductors and capacitors act as impedances in the phasor domain, but they depend on omega. So which omega should we use? And as it turns out to be that when we convert to phasor domain, we cannot convert both of the sources in phasor domain because they're operating at two completely different frequencies. So the only way we can use phasors to solve this particular circuit is by using superposition. So we will turn on one source, for example, the voltage source, and turn off the current source, and we convert everything using the omega 1 as 5, and then what we do is we turn off this source, we keep this source, and convert everything using the 10, and we just basically get the result that way. If we had any dependent source, dependent sources will depend on the other independent sources that are active. So if you had any dependent source somewhere here in the circuit, it will first operate at 5 and then it operate at 10, meaning keep it always connected. You don't turn it off. All right, so let's go ahead and just start solving the circuit. First off, what I will do is I'll turn off the current source, keep the current and the voltage source. I'll convert it to phasor domain and go from there. Yeah, but before I actually go ahead and start solving the circuit, we need to understand what we're looking for. We're looking for the V0 in here. Okay, so I'll compute the V0 using this source, and then I'll compute it using the other source, and then I'll use superposition just to add them in the time domain. Okay, so I went ahead and I copied the circuit a couple of times so that we can actually convert it. So the first thing I'm going to do is I'm going to turn off this source and keep this source on and just solve it using this. And the next one I'll actually flip which source is on, which one is off. Okay, so turning off the first one here. So if I turn off the current source, what I'll end up with is the following. I'll open, basically it's an open circuit. And now what I have in here is we decided that the omega here is just simply 5. But before we continue, this is actually based on sine, so we need to convert it to cosine first. So what I will do is I'll tell you, well, the voltage source in here, which is Vs of t, I'm just going to call it Vs, is 75 sine of 5 of t. Well, in order for me to convert a sine to cosine, remember, if I have the sine in here and cosine in here, what I need to do is I need to subtract the negative, basically, I need to subtract 90 degrees. So this will be cosine 5 of t minus 90 degrees. Okay, so that's Vs of t. And now I can go ahead and just basically convert it to V of s in terms of the phasor domain. So what we'll do is in here, we'll do the following. So this one here will be 75, and the phase angle is negative 90 degrees. Okay. And the other thing that we need to convert is basically this one here. It happened to be 0.2 F, and this one is 1 Henry. And as a quick reminder, what we have is J omega L for the inductor, 1 over J omega C for the capacitor. Okay, so the J omega L in this particular case is just simply 5 times 1, so it's 5J in here, and this is in ohms. How about the capacitor? The capacitor will be 1 divided by J, and omega is 5, and C happened to be 0.2, and that would be negative J omega. That's how much it will be. All right, so everything is there, but now also we just need to remember that this is not V naught, it's actually V uppercase V naught, and this one is prime because it's just partly because it's based on this particular source here in volts. Okay, so now how do we do this? So what we're looking for is we're looking for this V naught. Okay, and if you take a look at whatever we have in here, V naught is shared between these two. I think I can combine these in parallel and then apply voltage division. So voltage V naught prime is just simply the source, which is 75 times negative 90 degrees, okay, not negative, like with 90 degrees, negative 90 degrees, that's the phase angle. And what we have is we need to figure out what the combined here, which is a negative J in parallel with 5J, divided by negative J in parallel with a 5J plus 8. Okay, and the answer in this particular case, and by the way, this one here, you can complete it, it's basically negative 5 divided by Rj. That's what you get in terms of ohm. This is a combination of this inductor and capacitor in here. Anyway, if you compute this answer in here, what you'll end up with is 11.58. This is the magnitude, and the phase angle will be negative 171.12 degrees, and that's in volts. And that's basically in phasor here, okay? Okay, so that's pretty much the effect of the voltage source, and that's how we get it. So now we move on to the other side in here. So let me just draw a line so that we don't so you don't get confused between them. So what we have now is I have this circuit, and I need now to turn off the voltage source. So I'll turn off this voltage source in here, and of course by turning off the voltage source, I'll replace it with a short circuit. Okay, and now the current source in here happened to be 6 cosine 10t, so that is here is pretty much, I converted to phasor, that will be 6, and the angle is 0 amp. Okay, so it's no longer a phasor, or no longer a function of time. Okay, so that's how that is, and of course we need to convert this one here and this one here, and of course it used to be, I forgot what is, the omega 2 is 10, so let me just write it in here. So omega 2 is 10 radians per second. Okay, and just remember omega 1 was 5 radians per second in here. Okay, so we got that. So what's left? Well, this here, j omega L, the omega is 10, the L is 1, so that's here is just 10j. Okay, this is 10j. What about the capacitor? Well, the capacitor was 0.2. Okay, so it will be 1 divided by j times 10 times 0.2. Okay, so it's basically, I think it's a half or negative 0.5 of j. Of course, this one here is no longer V naught, it's uppercase V naught, and this is prime prime because it's the effect of the current source in here. All right, so how can we find this one here? Well, there's multiple ways to do that. We can combine these here, figure out the Z equivalent, and just multiply by 6 because they share all the voltage. Or you can use voltage, or you can use current division to figure out what the current in here and then divide it. But using current division, meaning you're going to have to combine these in parallel. So that's what I will do, is I'll tell you that the Z equivalent here is just simply 8 in parallel with the negative half of j in parallel with the 10j. And the way we usually compute it is 1 over Z equivalent equals 1 over 8 plus 1 over negative 0.5 of j plus 1 over 10j. So that means Z equivalent in this particular case is 0.03 minus 0.52 j ohms. Okay, that means V naught prime prime is just simply Z equivalent times that I, which is basically I just multiply it 6 with the angle of 0 times Z equivalent, and that answer will be, let me just write it here. I believe it will be 3.15, and the angle is negative 86.24, and that's in volts. Okay, so we figured out the V naught based on the current source and V naught based on the voltage source. So all we have to do is to combine them. So V naught is just V naught prime plus V naught prime prime. But as it turns out to be, you can't do that. And the reason why you can't do that is because this V naught is based on this frequency and this V naught is based on this frequency. So you can't add them because they're completely different phasors. They're basically rotating at completely different frequencies. And as it turns out to be, for superposition to work in this particular case, we need to convert the V naught into time domain and the V naught prime prime into its time domain, and we add them in the time after we do the inverse phasor. So what we need to do in here is we need to tell you V naught prime is just simply 11.58, and this time because we convert it using the cosine, okay, because we convert it based on the cosine, we say cosine, and the frequency in here is 5 of t, and the angle is negative 171.12 degrees, and that's in volts. Similarly in here, V naught prime prime as a function, this is a function of t, by the way, this is here will be 3.15, that's the magnitude, and also cosine, but this time it's 10t negative 86.24 degrees, and that's volts. So the way we combine them is now not in the phasor domain, but what we combine is the time domain equivalent. So V naught total will be V naught prime as a function of t and V naught prime prime as a function of t, which is a couple of sinusoids, which is 11.58 cosine, and this one is in 5t negative 171.12 degrees plus 3.15 cosine 10t negative 86.24 degrees, and that's in volts. So it's a combination of two sinusoids operating at completely different frequencies.